So now what we're going to be talking about is about the energy of a satellite in orbit around the Earth. So I have a satellite here, here's my Earth, and I have a satellite here, and we're asked to work out what is the total energy that it has if it's in orbit. So what is that? Well, first of all, it has potential energy. And that potential energy is equal to negative g m over r. Notice my m is a little bit bigger. One is this m and one is the mass of my satellite. The second thing it has is kinetic energy. And of course that kinetic energy is equal to a half mv squared. How do we work out the total energy since we're not given the velocity in this case? We're only given the mass. Well, the trick here to remember is that if you remember the orbital velocity formula, the velocity squared is equal to gm over r. So now we can substitute that straight in. So what we get is negative gm over r plus, now this is a half m, I'm going to put the 2 down the bottom in a moment, and now what we have here is g big M over 2r. And if you look very carefully, is that my potential energy here is the negative of twice the amount on this side. So if I twice multiply that by 2, then these two would cancel out, but I've only half of that here. That means my total energy, which is always going to be equal to U plus K, is going to be, if you cancel that out here, is going to be equal to negative G m little m over 2r. That's the formula for the total energy of my satellite, because it's simply the sum of those two things here. We can now actually calculate it all out, and so what we get is negative 6.67 by 10 to the power of negative 11 multiplied by our mass of the Earth, which is 6 by 10 to the power of 24, multiplied by the mass of our satellite, and we're told it's 50 ton, so that's multiplied by 50,000 kilogram, and then divide that all by twice the radius here. Now remember, the radius is actually equal to the radius of the Earth plus the altitude. So I have 6,371 kilometers, which is the Earth radius. I have to add the 500 kilometers of the satellite, but I have to multiply all this by 10 to the power of 3 because I have to have this in meters. And when you calculate all this out, you're going to get a value of 1.47 by 10 to the power of 12 joules. But of course, lastly, this is a negative value. So that's helped you hopefully understand how we work out the total energy of a satellite in orbit. My name is Paul from High School Physics Explained. Take care. Bye for now.